Hello and welcome everyone. My name is Szabo. I'm an application engineer at Gamax Laboratory Solutions, and today I would like to talk about how can we create a reduced order model based on neural networks in MATLAB. So AI is part of our everyday lives. We can find AI solutions in many kinds of everyday products like speech recognition in speakers, face detection for cameras, self-driving systems in the automotive industry. If we would like to develop a similar system that we have talked about earlier, we have to go through all of the 4 stages of the AI workflow. First of all, we have to prepare the data. Then we have to create the algorithms and tune our models. We also have to test the models in a simulation environment. And finally, we have to deploy the models into the field. So let's see how does it look like in a real-world scenario. In this example, we want to estimate the internal temperature of the motor. For commercial use, it is not feasible to build a sensor into the motor. That's why we have to create an AI model that can estimate the internal temperature of the motor based on the input signals. This AI model can be called a data-driven reduced order model. So what is a reduced order model? Reduced order modeling is a set of techniques for reducing the computational complexity or the storage requirement of a computer model by preserving the expected fidelity with a controlled error. So why it is important? Because you can speed up the system level simulation in Simulink, you can use them in hardware-in-the-loop testing, you can develop a virtual sensor and the digital twins, but how you can build the models like that? There are many ways how you can develop a reduced order model. Firstly, you can build a physical-based models using mainly Simscape products to tailor your simulation for the right timescale. Then there are model-based techniques that enables you to use the reduced version of third-party tools in Simulink. You can also build up linear models. So if you are working with non-linear Simulink model, you can linearize it to reduce the number of the states and use the resulting linear model to speed up the simulation. And finally, data-driven techniques. You can start the development by developing experiments to collect the input and the output data from high-fidelity first-principle models. With that, you may develop a static ROMs like curve fitting and lookup table methods. Or you may create a dynamic ROMs where you can use the input and the output data to train the AI model using machine learning, deep learning, or system identification techniques. Right now, we were going to focus on that today. So this is the full spectrum of the solution that goes from black box models in the left to the first principle models to the right. Let's see the advantages and the challenges of these topics. Regarding the first principle models, you may develop an accurate model with a high fidelity. You will have a clear physical meaning, and it does not require any kind of data engineering. However, on the other side, it can be challenging to derive the model. It requires signification calculation time, and you need a knowledge in the respective domain. Regarding the data-driven models, you may succeed when first principle models are unavailable or impossible to find. You may reduce the complexity and simulate faster. You can build on the measured data and do not require any kind of domain knowledge. However, it requires lots of data that it's hard to explain the operation of the model. Tuning the model is not just revise some parameters, you have to retrain the whole model. The good news is that you do not have to choose between the first principle and the data-driven models, they can coexist. So as a quick recap, let's see what have we learned yet. Reduced order modeling can reduce the computational complexity or storage requirement. Data-driven models can be developed based on the inputs and the outputs. And right now, we will be focusing on the dynamic data-driven models. Let's see how we can build a data-driven model with MATLAB through an example. So this is the example that we are going to use today. We will see how we can replace the first principle engine model with an AI-based techniques. So this is how the top level of the model looks like. As you can see, we have components that represent the driver, the controllers, the vehicle model, the road conditions, and the visualization. The objective of that model is to control the velocity of the vehicle based on the driver input, so this is a closed loop system. Now the passenger car subsystem models the entire vehicle, so the wheels, the differential, vehicle body, and the vehicle engine. These can be modeled with MathVerse tools, but you can also import components designed in third-party tools into Simulink. In these situations, where there is a high level of fidelity and detail, the Simulink model will be complex and often results in a slow simulation time. In this example, we will see how we can replace a part of a complex vehicle model with a data-driven model that is estimated and trained in MATLAB. In this case, the inputs of the AI model will be the engine speed, ignition timing, the throttle position, and the wastegate valve values. The output will be the engine torque. In order to start the development, we need training data. There are various ways to get the data for your training. You could be using a public data set, you could generating experimental data from physical system, or you could also generate synthetic data from simulation models. MATLAB and Simulink allow you to do it in various ways. Today, we will focusing on the data that's directly generated from Simulink and Simscape model. The first step is to develop a set of experiments that we want to generate data from. Then we can run the respective simulations in Simulink. Finally, we can collect the data that we need. In any kind of other problems, you may generate a synthetic data from other techniques. These techniques may include generate images using GANs or using visualization environments like Unreal Engine. The next step is the AI modeling. So we have to choose what kind of architecture we would like to train. If you look at the different data-driven approaches of the ROM, we can think of static or dynamic methods. Static methods include lookup tables of curve fitting or surface fitting techniques. Dynamic methods include deep learning methods like LSTM networks, neural ODEs, nonlinear arcs models, and couple more. For this example, we are going to use an LSTM network to be able to capture the time dependencies in our data. An LSTM network is a type of recurrent neural network that can learn long-term dependencies. As previously mentioned, the inputs of the model will be the engine speed, ignition timing, throttle position, wastegate valve, while the output of the network will be the engine torque. Let's see how we can create such a model in MATLAB. First of all, we need to open the Deep Network Designer and look for suitable network architecture. There are many types of pre-trained neural networks that can be used, but right now we will choose an LSTM network for sequence classification. We choose the network and then we can fine-tune the architecture and also modify or set up the parameters of each layer. We can also analyze if there is any kind of error in the model. Finally, we can generate the code to create the architecture inside MATLAB. Now we can build our own neural network to set up the training options, then we can start to train the neural network. As you can see, we can also check the training process. Finally, we will test the trained neural network. We can see the results in root mean square error, and also we can check the accuracy of the trained neural network on the test sequence compared to the ground truth. The next step is to integrate the trained neural network into Simulink model. In order to do that, we need to use the existing Simulink blocks that are included in toolboxes like machine learning or deep learning. This makes bringing AI models into Simulink extremely simple. We also know that new models are coming out all of the time. That's why we support importing models from TensorFlow, PyTorch via Onyx, so you have the opportunity to work with them within the MATLAB environment. Once they are in MATLAB, you can easily use them in Simulink in the same way that we have seen today. Furthermore, if there is any kind of additional method is missing from MATLAB, you can use the MATLAB function block to implement it into Simulink. And finally, here is the system level model where we run the AI model in closed loop. Running the simulation, we see the target and the actual velocity match in the bottom of the scope and the engine torque on the top of the graph of the scope. If we go into the vehicle subsystem, we can see two variant implementations where the active one on the right uses the LSTM model we trained earlier. After we successfully integrated the AI model into Simulink system, we use the Simulink profiler to test the two variants runtime. On the left, you can see the first principal model's runtime, while on the right, the results of the LSTM model can be seen. By using the ROM methods, we have reduced the runtime from 100 sec to 5 with the LSTM-based model. As a summary, we have seen today how to start developing ROMs and create training data for our AI models. We have seen today how to use deep learning techniques to replace the first principle models. Then we have successfully integrated a trained neural network into Simulink for system-level simulation. With that, I would like to thank you all for your attendance, and I'm looking forward to questions. Thank you very much.
And that was reduced order modeling based on neural networks with Lorant, Szabo, application engineer here at GAMAX Laboratory Solution, and our lead developer on Biomedical Solution that you heard about in the opening remarks of this conference. Now, Lorant is right here with me in the studio, so if you have any questions, now's the time to put them in the chat box, which is on the right side of your screen, and we will be happy to answer them all. Hi Lorant, welcome.
Hello, thank you very much.
So, AI,
Yes.
that's a big topic.
That's one, yes.
I do have a questions, but before we get into it, I know that you prepared the poll, so maybe we can run it and then go some questions, okay?
Okay, absolutely.
Great, so we can start the poll. Right now on the right side of the screen, you can see a poll button. If you click on it, it will open a poll window. Just submit your answers and we will come back to them shortly. So AI,
Yes.
big and trendy.
Yes.
What does it take to keep up with such a topic, which is every day there's so many new things?
In my opinion, it is impossible to track all of the papers, yes, and all of the results in that topic. Personally, I use some forums, Google Scholar, in order to keep up with the trends and the architectures that the lead developers using right now. So it is hard, and I think it is impossible in some way. But if you choose some kind of subset of the deep learning and this topic, in that case, probably you can track the most important papers and the architectures.
Something like counting the stars in the sky.
Yes,
Impossible to do.
Something like that. Yes.
And if you talk about MATLAB, is it any different? AI in MATLAB, is it hard to keep up?
Basically, it's the same up to a certain point. So you know that there are lots of cases when you, for example, find a paper on Google or on anywhere else on the internet, and you scrape it and try to replicate the results that you found, and sometimes it's fail. And that's why it is probably more convenient to start your development in MATLAB, because the pipelines in MATLAB is already tried out and they are working. So if you start a new development or in the topic, probably you should go with MATLAB first. Try the basic architectures and the basics example of MATLAB, and in that case, probably you can go and tune your model up to a higher level.
Yeah, but I mean, I guess at the end, even though it takes so much time to research it and keep it up, because considering Maya and it's like AI medical assistant, that's such a big thing.
Yes. For me, it was absolutely a new topic, because I'm come from automotive industry. But after a certain time, thanks to MATLAB, I could use the built-in pipelines and the built-in examples and the architectures made it possible to keep up and ramp up myself in that industry as well. So.
And can I ask, how long did it take you to go from different industries and specialize in AI, and now you're the lead developer, so you're the person?
Takes a while. I would say it takes about 2 or 3 months to ramp up myself in that topic. But regarding, we are talking about deep learning, the most of the papers basic architectures could be the same. So that's why it is nothing. It's not a totally new topic, but you have to probably use different architectures and pipelines than the automotive industry.
Okay. Well, thank you so much for answering, and I think we are ready to close the poll.
Yes, absolutely.
So we can close the poll and you can see the results. And what would you make of that?
Well, that's why I made a presentation in that topic, and I tried to draw the attention for that possibilities to use AI for reducing the computational complexity, since most of the cases we are always talking about processing images and so on and so on, and we do not care about how can we use AI for different purposes, like reducing the complexity, reducing the requirement of the memory, and so on. So that's why I wanted to give the presentation in that topic, because I think it's interesting and relevant right now.
Well, I hope our audience learned a lot from your presentation.
I absolutely see, and I hope so.
And we have a lot of questions.
Oh,
Are you ready?
Yes, absolutely ready. I try to.
Okay. Do you consider LCTM the most promising type of ANN dynamic model? Could you comment a bit on that?
Yes, absolutely. So they are very promising, and personally I use LSTM networks for lots of application and lots of purposes. So some other research and development projects, I use these kind of neural networks and layers to reduce the complexity of, for example, a powertrain model or a fuel cell model and so on. So they are very promising, and we can see that they actually work. So that's why we should go for them and consider them to use.
Next one. What algorithms do you implemented for training the AI neural net in the presentation? In your presentation, what algorithms for training?
Basically, I used LSTM networks in order to reduce the complexity of that high fidelity model that you could saw in the presentation. So this two question is one. Yes.
I hear a lot about GANs. Could you give an example of where GANs are used in the industry?
Yes, so basically we use GANs for creating new images or new data sets. So for example, they are used for example, you have an environment perception module, like in an autonomous vehicle, and that's why you have to somehow simulate the environment for that autonomous sensor cluster, and this is where GANs can be used, because you can generate new even photorealistic images from texts and from other inputs, and in that way you can generate image data sets, even image data sets for your environment perception pipeline. And also you can probably saw for example a parking system in a more developed car, when you can see that more video streaming coming, and you make one images from the lots of cameras. This is where GANs are used to blend the many video streams into one image. So yes, they are used widely in the industry.
Next question. I understand that it's good to reduce the simulation time, but could you mention other use cases where it is important to reduce the computational time?
So basically, reducing the computational time is just one advantage of using reduced order models. But sometimes you have a high fidelity model that runs great on your desktop, but you would like to deploy it somehow into an embedded system where you have a reduced system requirements. You do not have enough memory. You do not have a powerful CPU or something like that. And this is where a reduced order approach can be useful, because you can use these models to replace the high fidelity model, and in that way you can deploy them into an embedded system or something like that. So deploying is other stuffs where reduced order modeling approach can be helpful.
Is there any other?
Is there any other? Well, of course, regarding reducing the simulation time, you reduce costs of the development. We also talked about the deployment. So these stuffs are the main reason why we are using them.
One more question. That's from me. It's very important.
Okay, very
important. Are you ready?
Absolutely ready.
Will AI take over the world?
Absolutely.
Yeah, I knew it. I knew it's gonna happen.
We are working on that.
Yeah, great.
Yes.
Thank you so much for being here today and
Thank you
for
very much.
taking your time. And I know, Ismail, you're really, really busy, so we do appreciate it a lot.
Oh, thank you very much.